All right, so this is video lesson number 24. This is going to be comparing speeds of two different objects. Now, here's our graph that we're going to get back to in just a second. What we're going to do is compare the speed of a fox to the speed of a squirrel. Notice we have our time across the bottom, and then we have our distance over here on the other axis. So we're going to put time, and it's going to be in seconds, of course. So we're going to come back to this in just a second. I do want to talk about the notes that are on page 104 that go along with video lesson 24. So real quick, I want to touch on these important pieces. So it says using a graph to compare the speed of two different objects. Now in this case, we're going to compare a red line, which is a rabbit, to a blue line, which is a turtle. So what we're going to do, and I'm going to zoom in a little bit here so you can see a little bit better. So the first thing that you have to do is plot your data points. All right, and we're going to practice doing that in just a second with the whiteboard that I showed you to start the video with. But for now, I went ahead and put in some data points, and you can tell the red line is a more steep slope compared to our blue line here. Notice that both lines are straight, indicating that both objects maintained a constant speed. And our example question might be something like, how much faster is the rabbit than the turtle? So step one here is we're going to have to find an ordered pair for the rabbit to calculate the speed of the rabbit. So I went ahead and did that, and we picked 3 seconds. And if we go to our x-axis and pick 3 seconds, we can go up and see that our corresponding y variable is going to be 15. So we'll have 3, 15 here, and I wrote that down there, 3, 15. And then we're going to go ahead and do our math like we normally do, just box in our 15. So 15, 3, and when we do the math there, 5 times 3 equals 15 with the remainder of 0. Therefore, our speed of our rabbit is going to be 5 meters per second. Now remember, that is just step one. We got a lot more work to do here. So step 2 is find an ordered pair for the turtle and calculate the speed of the turtle. So let's go ahead. I picked out 4 and 10. So we're going to go along our x-axis here and find 4, and we're going to go up and find our corresponding 10. So 4, 10 is going to be our ordered pair for our turtle speed. So we'll go ahead and put in 4 and 10 into our formula here. So we'll box up our 10, and you can tell that, let's see, 10 here, and you got 4, it goes in there twice. So 2 times 4 is 8 with a remainder of 2. And then we'll bring down our 0, and then that gives us 20. So 4 goes into 25 times. Don't forget to put your decimal points in the correct spot. 5 times 4 is 20, leaves us a remainder of 0. So 2.5 meters per second is our speed of our turtle. So now we have the speed of the rabbit at 5 meters per second, and we have our speed of our turtle at 2.5 meters per second. Step 3 now is to subtract the two speeds to see the difference. So we're going to take our speed of our rabbit, which is 5 meters per second. We're going to subtract 2.5, which is our speed of our turtle, which is going to leave us with a difference of 2.5 meters per second. So if we go back up to our question asks, how much faster is the rabbit than the turtle? Well, the answer to that is 2.5 meters per second. So a lot of work to accomplish one of these questions. Don't forget all 3 steps. Step 1 is find our rabbit speed. Step 2 is find our turtle speed. Step 3 is subtract those two to find the difference. All right, that's the end of lesson, the note part of lesson 24. So real fast, what I'd like to do is an example, and I've already made up some data points for this. So we'll do this as quickly as possible. If we take our fox, and our fox is going to be in red, we'll go 1 and 10. Then our next data point is 2 and 20. And then our next is 3 and 30. And then 4 and 40. So if we plot our line for our fox, we know that we are looking at a straight line that's angled like the red here. And let's go ahead and look at our squirrel. So our squirrel is going to be 1 and 5. And then 2 and 10. 3 and 15. 4 and 20. And so then we'll go ahead and plot our line. So our squirrel is the S, and our fox is going to be with the F. Now once we have established, we know that our speed of our fox is going to be faster because the line is more steep. The speed of our squirrel is not as fast. based on the slope. So what I'd like to do now is go ahead and we're going to copy our information there. I'm going to flip back and forth between this whiteboard and this piece of paper here. So first step was to find our Fox speed. So we have to find an ordered pair. So let's do 2 and 20. All right, so we know that we're going to box in our 20. All right, so doing our math here, we know that 10 times 2 is 20. It leaves us a remainder of 0. So 10 meters per second is the speed of our Fox. Okay, that was step 1. All right, our step 2 is going to be our squirrel speed. And so we're going to do the same thing. We're going to pick a spot. It's easiest sometimes just to pick the same data points. So we're going to pick 2, 10, and then we're going to box in. So 5 times 2 equals 10. Subtract that out, we have a remainder of 0. So now we have a 5 meter per second speed for our squirrel. So now we know that step 3 would be to take 10 meters per second for our Fox and 5 meters per second for our squirrel. And when we subtract those out, that is going to be our difference in speed. Is going to be 5 meters per second. So very long process here. It takes multiple steps. It takes a lot of endurance to get through one of these questions, but don't give up, and we have a lot more practice to do on these.